All right, this is the first of a two-parter video. So I'm gonna go over the problems that we went over in class. I'm not gonna go over every detail. I am going to explain the steps to you. So if you can, please write the steps on a separate sheet of paper and rewrite the problem if you need to, so that you can really process the information. For every page that we did in class, I'm gonna show you that actual page, but it's gonna be cut in half afterwards so that we can more easily focus on one problem at a time. Once again, just pause the video whenever you need to, but I am going to try to make it all inclusive so that if you really need to rewind the video and watch it a little slower or speed up, it should have all the parts that you need to, so that you can fully understand the problem. So let's get started. For these graphs, all you're really required to do is you should always start with the actual graph, and then what's going to help guide you graph the rational function is start with the asymptotes. There will always be a vertical and horizontal, and in this case you will have a vertical asymptote shifted because of this horizontal shift, and then same thing here. Okay, the -1 over here is going to affect the horizontal asymptote, and it's going to go one down, right? So let's get going here. For this first function, we're going to have a horizontal shift where there's going to be a vertical asymptote at 1, okay? Because that's what makes the denominator 0. And then we're going to have a horizontal asymptote at -1, okay? That's because it should be at 0, but because there's a vertical shift down of 1, it moves the horizontal asymptote as well. And so why was there a horizontal asymptote at 0? Because the numerator, the exponent of the numerator is less than that of the denominator. And as far as the parent function goes, you should kind of remember that. We took some notes on how these parent functions should look like, so I'm not really going to cover that in this video. And then the next one, g of x, is going to be same thing. So start with where there's going to be a horizontal asymptote. Because there's no vertical shift, the horizontal asymptote should be at 0. However, there is a horizontal shift, so there should be a vertical asymptote at -3. Okay. Now this is x squared as well, meaning this is squared and it's also negative, so negative means the graph should be facing down. Because this is the squared version, this is the way it actually looks, right? Again, don't focus on the x-intercepts, y-intercept, or any of that. Just focus on how the asymptotes shift, and then graph the function based off of your knowledge of the parent function. Okay, we're done with that. Now, this particular problem, you're going to find all intercepts and asymptotes. So everything you really need is right there. So x-intercept, y-intercept, vertical asymptote, and horizontal. Now, one of the first things you want to do is you don't really want the quadratic to look like this. You want it factored, okay? So I did the liberty of starting this little thing right here on the side, showing you how to factor. So -15 goes on top. That's a, b, c. So it's a times c on top, b on bottom. Okay, so two numbers that multiply to the top and add to the bottom. You should have the following. Again, pause the video if you need to. This one should be positive because 5 times -3 is -15, but when you add that, it'll be 2. Cool. And the bottom is already factored. Okay. If I make any small arithmetic error, go ahead and just shoot me an email, and I'll let you all know where that mistake is, so that you're not really repeating that. Okay, for this one, you're gonna need to just factor out an x. There's nothing special about this. So if you factor out an x, you should end up with 2 minus x on top, and on bottom is x minus 1, and then x plus 1 squared. Okay, so now we can get started. So x-intercept is always set the numerator equal to 0, right? So by doing that, you set each factor equal to 0 for the numerator, and then you get your answer. So for the top, it's negative 5, and 3. Y-intercept, we're not going to go too into that, but you plug in 0 for all your x's. So for this case, if I did do it correct, it should be 15 over 2, okay, when you plug it in. For vertical asymptote, it set the denominator equal to 0, okay? So same thing like the x-intercept, but for the denominator, because you cannot have 0 in the denominator. So those values are x equals 2 and negative 1, okay? So there's going to be an asymptote at 2 and negative 1 for the vertical. And the horizontal is the little tricky one, but it's really easy once you get it down, right? You need to compare the highest power of the numerator to the highest power of the denominator, but you can't see the highest power when it's in factored form. So all you have to do is multiply the first two terms like that. So I'm going to write it here on the side. So it's x squared on top, x squared on bottom. And when you have the same exponent, you take its ratio. And in this case, it was 1 over 1. So the horizontal asymptote is at y equals 1. All right. So similar process with the bottom one, right? So to get the x-intercept, set the numerators equal to 0. Okay. So you should have two values, x equals 0 and 2 for the second one. 0 and 2 for this one. Y-intercept is plug in 0. If you notice, because of this value right here, 0 times anything is 0, and we don't have 0 at the bottom. So 0 over some number is 0. So we have a y-intercept at 0. Okay. If you notice, I didn't put y-intercept, y equals 0 over here, and all you did over here. You don't always need to label it like this if you put x-intercept and y-intercept. However, for vertical and horizontal asymptotes, you always have to do it because it's an actual line reference that you draw on a graph. Cool. All right, so vertical asymptote, set the denominator for the second one equal to 0. And so you have two vertical asymptotes. It's negative 1, and 1. Okay, and then the horizontal, I look at the powers. If you see on top, there's two x's, so that's negative x squared. And on bottom, there's two x's here, and then one more here, so that's x cubed. So it's negative x squared over x cubed. When the denominator power is bigger, you have a horizontal asymptote at y equals 0. So y equals 0 is your answer here. And that's it. On to the next one. So consider the quadratic. In this case, we're going to try to keep it a little bit simple, okay? I've already partially have done it, okay? So let me explain here. So to find the vertex, you really need to just find this formula right here, okay? So to find the x of the vertex, this is what that is. So it only gives you the x. Once you get this value, you plug it into your function, and that gives you the y of the vertex, okay? So I already did the math a little bit. Remember, I showed you previously A, B, and C is the label. A is 1, B is negative 3, and C is negative 28. This is one of the problems I fixed. In class, it was +7. It should have been negative 28. Because in class, it wasn't factorable. So, whoopsie. Okay. So what two numbers multiply to negative 28 and add up to negative 3? Those two numbers are negative 7 and positive 4. So these will be your factors right there. X plus 7 and x. So x minus 7. And then x plus 4. Okay, so those two multiply to negative 28 but add up to negative 3. So the x of the vertex, okay, is going to be negative b over 2a. And then I plugged in the values, and it should end up with 3 over 2. Now, this is a little disappointing. It should not have been a fraction, but it is what it is. If this is on the test, it will not be a fraction, okay? That makes it easier for you all to plug it back in without any issue since you don't have a calculator. So for the vertex, it's going to be 3/2, and then your output is going to be the y, and that y value is whatever you get when you plug this in to x and do the math with this function right here. Okay, so for now we'll just leave it as y. The axis of the symmetry, it's actually very easy. You already have it when you get the x of the vertex. In fact, that's what it is. For b is equal to, so x equals 3/2. But this case is not for the vertex. This is just because this is the axis of symmetry. So a better way to write it is actually just write axis of symmetry at 3/2, right? But don't be too caught up with how it's written, right? A lot of times people write it as x equals 3/2. It's fine, right? As long as you're labeling your answer as b. Intercepts, that's where you had to factor. This is why we factor. It's for the intercepts. We're trying to find out. This is basically going back to x and y. So to find the x, you set these equal to 0. So in this case, you're going to have x equals 7 and -4. But to find y-intercept, I'm not going to tell you the answer. But y-intercept, remember, is whatever you get when you plug in 0 and do the math with these numbers right here. So it should actually have been -28, right? So your y-intercept should be -28 when you plug in for 0. Again, disregard this +7. Okay, and the last one, sketch using 3 points. That's what it's going to say, okay? But we're not going to get too caught up with this, considering that we have much more difficult problems to worry about. But in this case, you should at least be able to put the x-intercepts, okay? And then know that this graph is facing up, right? So it should be something like this. As long as you do this, you'll be fine, right? We're not going to be super caught up on this, considering the other caliber of questions we have. So we're done with this. On to this one. This will be the last problem I'll stop with, because I have like 3 minutes and 30 seconds before I reach the 15-minute mark, which I'm trying to keep the videos at. Okay, so for this one, this is the one that causes most people problems, but we're just gonna keep it straightforward, okay? The best way to do this is step one. Step one is to make sure that your numerator and denominator is in factored form, because that's the easiest way to put the values onto the number line. Now, how did I know that it was this? Remember that there's a set of problems that you need to remember where x squared minus 16 is equal to x minus 4, x plus 4, right? They're all difference of squares. X squared minus 49 is x minus 7, x plus 7. Similarly with this one, x squared minus 1 is really x squared minus 1 squared, which is x minus 1, x plus 1, okay? So set all of these equal to 0, and then all those numbers, you're going to solve for x and put on the number line. So for the top left, you're going to get x plus 1, which is going to equal -1 when you set it equal to 0. Okay, when you do the right one, x minus 1 equals to 0, you should get x equals 1. And then the bottom is -2 as your value. Now, step 2 is open close circles. So if you notice, this is an inequality with the equal sign. So the numerator will always be closed. However, the denominator, no matter what this inequality looks like, because it's in the denominator, it always has to be open. So this is open, this is closed, and this is closed because of the inequality. Now, last step, true test points for true false, right? True means that's part of your answer. False means that it's not your answer. Okay, and you'll see how. So test point will work out one test point. Test point is 0, always the best one. So that means I'm going to show you real quick 0 plus 1, and then 0 minus 1, all over 0 plus 2. And if you notice that, that is equal to -1 divided by 2, so -1/2. So now you ask yourself, is -1/2 greater than or equal to 0? No, it's not. So at this point, this fails. So that means for this interval, that's a fail. Now, you really want to get this next part down, okay? That is, try to remember the multiplicity. So this has a multiplicity of 1, multiplicity of 1, multiplicity of 1. Multiplicity of an odd number means that it crosses. An even multiplicity, let's just say this was 2, that means that it'll bounce. So let's just say this had 2. Then that means at this value right here at 1, not 1, sorry, if this had 2, then at this value at -1, because it has 2, your graph will bounce and remain the same false over here, okay? But when they all are odd like this, they will all cross. So they alternate true, false, true, false, true, false, starting with the one that you did. So false, true over here to the left, and then it's false. So the true intervals are your answer. And always do not forget that this is going to be parentheses, bracket, and then bracket over here. Okay, so it's -2 to -1, bracket, union, bracket to 1 to infinity. And you do not include the false intervals, right? So one last time, we got lucky here because these closed circles ended up being the starting or ending of a solution, so we don't have to really worry about anything special. But aside from that, that's all there's to it.